I am Dr. Charles Yarish, a professor at the University of Connecticut in the Department of Ecology and Evolutionary Biology. I would like to introduce you to the cultivation of two seaweeds. They are closely related to one another. They are called Kappaphycus and Eucuma. These seaweeds have a great deal of value, principally for providing a cultivated source of carrageenan. Kappaphycus has many different species, but the principal species that is cultivated in Southeast Asia, in the Philippines, Indonesia, Malaysia, and also in the Indian Ocean, in the areas of Zanzibar, the species is Kappaphycus albrezii. It produces a carrageenan that is called kappa-carrageenan. Another species of a closely related red species called Eucuma denticulatum, produces another type of carrageenan called iodocarrageenan, and these different types of carrageenans have different food applications in various industries. So what does Eucuma and Kappaphycus look like? Basically, they are very robust red seaweeds grown naturally in subtropical and tropical regions of the world. The economic species are the ones that I've just described, Kappaphycus albrezii and Eucuma denticulatum, that are producing carrageenans. And here are some of the cultivated Kappaphycus plants that are being cultivated in the Philippines. The country leading right now in Kappaphycus production is Indonesia. Closely related behind Indonesia in production is the Philippines and also Malaysia. And then another area where Kappaphycus is being farmed is right now in the Indian Ocean off the island of Tanzania called Zanzibar. Now, there are many different strains of Kappaphycus. Each one of them have a particular application and a different type of carrageenan, as I had mentioned. They have different colorations as well, but most important for these different strains is the quantity and quality of the Kappaphycus that is required by the carrageenan industry. So how do you cultivate the Kappaphycus and Eucuma? Basically, you go out and you can harvest the plant, and then you can fragment the plant. And today, the cultivation of Kappaphycus and Eucuma is principally the same all over the world. You have your plants that are being maintained now in nurseries, and these plants, you can fragment them up and you insert them in lines or tie them onto lines, and you can produce a Kappaphycus or a Eucuma plant that can be many kilos in size. Like you can see the diver holding one Kappaphycus plant. But you can grow these there on lines underwater, and this is how it is principally grown in subtropical and tropical countries. So in the areas of Southeast Asia where the Kappaphycus and Eucuma are grown, they're grown on lines that are in the sea. However, if you go to Asia, if you go to Zanzibar, the Kappaphycus is actually grown in areas that are intertidal. And so the lower pictures, they are showing the intertidal cultivation of the Kappaphycus of Zanzibar. And the industries, interestingly enough, in Africa is dominated by women who are very, very active. And there were roughly 15,000 families in Tanzania's Zanzibar area that are involved involved in the Kappaphycus production. If we look at Kappaphycus production in the Philippines and Indonesia, probably we're looking at anywhere from 40 to 50,000, maybe 60,000 families in those countries, leading to upwards of 1 million people involved in the cultivation of this red seaweed called Kappaphycus. Now, Kappaphycus can be grown in the water. And how do you grow the Kappaphycus? Well, you have a source of the material, you break it up to certain size fragments, and you tie these fragments onto your lines. This technique of tying to the lines is sometimes referred to as the tie-tie technique. And after 8 or 9 weeks there, you'll get plants being formed, and you can wild harvest the lines. Normally, you may be able to get 2 cultivation, maybe 3 cultivation crops of the Kappaphycus or Eucuma every growing season. But it really depends on the culture that you're doing the work. And here is a picture of Kappaphycus growing on a farm system in southern China on the island of Hainan. And you can see the Kappaphycus crops growing, and you can get some very sizable plants of the Kappaphycus plants. Now, when you're looking at production costs of growing Kappaphycus, it's very labor intensive, and roughly about 66% of the production is labor. And so savings of labor is going to be very, very important. How do you deal with the growing of the Kappaphycus? You can seed your lines, as I said before, with fragments. You can tie the fragments onto your lines, and in this particular case, you're looking at lines that may be 10 meters in length, but they could be longer. But it takes time to tie the material onto these lines. The grow-out cycle give you an idea about how long it takes to seed a 3,000 meter farm system. A lot of hours, 75 hours. And when we look at replacing the farm system after a harvest, that will take another 75 hours there. So you can replace your farm system after harvest every 1.5 to 3 months, depending on where you're growing the material. But this is a very labor-consuming cultivation process, but one that works very nice, especially in lesser developed countries. After you do the growing and the harvesting, you harvest plants that are about 1 kilo in size, taking up to 45 days. You take the harvested plants and you can dry it. You can sun dry it for a period of time. Usually takes a few days to sun dry it. You want to bring the plant tissue down to have a moisture content of about 30%. Less moisture, you'll get more value for your product. The quality will be very important, and you've got to make sure that if there is a rain event coming, you have to cover your Eucuma or your Kappaphycus crops so they don't rot while they're following a rain event. After you dry these red seaweed there, you will bale them and you'll get them ready for sale, and then they can be shipped to a processing facility to extract the carrageenan from these plants. And you can see here's bales of the carrageenan being carried by these individuals there. There is some dried carrageenan that has taken place. Notice the transporting itself is also very labor intensive. Anyway, you can't transport it to an area where you can bale it, just adds to the cost. But in less developed countries there, labor costs are low, so you're able to depend on your source of labor for transporting the crops and baling the crops for market. Now, what do you do with that handling of the material? You take your dried material, and you got to make sure there are no sand, no stones in it, no dirt, because that will also devalue your crop when buyers buy your material. If buyers open up a bale and they see stones in there, they will give you less for your product, and that is not a good situation. And buyers are very cognizant of ways that people will try to increase the weight of their baled material. And here is just a picture of the product going into a factory. You extract the carrageenan through a technique using acid-based solutions there. In this particular case, the extracted carrageenan is pulled out with sodium hydroxide. You can freeze-thaw the carrageenan so it solidifies, and you can then sell it as a gelled product, or you can take that product and dry it out and make a powder. And that is how it is produced in the United States at a company that is called Marine Colloids. DuPont Dow is the parent company of Marine Colloids, and Marine Colloids was the company that pioneered the extraction of carrageenan from red seaweeds, and today they are extracting carrageenan from Kappaphycus, from Eucuma species, and also some of the wild harvested Chondrus crispus is also another source of carrageenan. After the seaweed is basically made into a powder or a gel form, it could be sent to market by your carrageenan producers. And so today we've introduced you to the open water cultivation of Kappaphycus and Cuma, two closely related species that are the principal sources of carrageenan for the global phycocolloid market.